Welcome to the 10th module. In this, our final module, I shall discuss classes in C++. These are a special type of structures that allow us to group related variables and functions together, similarly to how functions group together statements. I will be explaining how they are formed, defining concepts such as class declarations, class definitions, member access, constructors, destructors, and constant members. Before I discuss classes in C++, we need to take a look at our current programming method. Up to this point, we've approached programming problems in more or less the same way. After a problem has been identified, we proceed to making variables to hold the data we need and then make functions to operate on that data. This programming method is known as procedural programming. By means of using classes in C++, we give way to a new programming method known as object-oriented programming. In procedural programming, a problem is approached by specifying a series of instructions in which it is to be solved. Data is stored in variables and functions are made to operate on the data. Functions and data hold no inherent relation with one another. That's been our approach until now. In object-oriented programming, a problem is approached by grouping variables and functions that are related to one another into objects. Similarly to how we group programming instructions that work together into functions. These objects, then, are composed of data known as attributes and functions that use that data known as services. The problem is solved by interacting with these objects. I will be discussing later how this is implemented in C++. But first, let's offer an example. If we were to determine the area of a rectangle and print it on the console, through procedural programming method, we would create two variables to represent the width and height of a rectangle, then multiply the two variables and print the result as the area of the rectangle. Through object-oriented programming, we would create a rectangle with a given width and height, and then have the rectangle print out its area based on its width and height. Although the benefits may seem unclear with this example, as programming becomes more and more complex, approaching problems using the object-oriented programming method allows programs to be much less error-prone, flexible, and easier to create and maintain, similarly to what functions did to just writing instructions in a program. Different programming languages have different approaches to allow the use of object-oriented programming. C++ implements it by means of classes. Classes are the way that objects are structured and manipulated in C++. They are not objects. They define the type that an object is. Example, a Ferrari is a type of car. Consider them as blueprints of an object, how it is designed. Here is an example of how classes are made. You use the class keyword followed by the class name. Afterwards, you open a pair of brackets and inside you declare but do not define the variables and functions that make up the objects of that type. And finally, you close the bracket and finish it with a semicolon, similar to a statement. Remember, an object is a group of variables and functions that work together. From the previous example, we see how a rectangle class should be structured in C++. Some components have been omitted to be discussed later. First, we write the class keyword followed by rectangle, the name of our class. Inside the brackets, we declared the needed functions for our objects, width and height, and below that we write the declaration for the printArea function, which, as the name implies, prints the area of the rectangle on the console. This is a simplified example of a class, as some elements are missing. As we progress through these concepts, they shall be added one by one until we have a completed structured class. Since an object is a group of functions and variables that work together, you may not always want external functions outside the object to interfere with its operation. For example, changing the value of one of its attributes. To avoid unwanted change to an object, access to the components of a class are restricted. A program cannot use or even see functions and variables from a class unless the class itself has allowed access to them. This has to do with scope. For a function that does not belong to the object, the variables and functions that make up that object do not exist, similar to how variables declared inside a function do not exist outside of it. It's good to note here that the attributes of an object do keep their values after they are used, similar to a static variable. To grant access or deny access to components of a class, the keywords private and public are used. In the class definition, these keywords are referred to as access specifier functions. Variables declared under private are restricted. Only the class itself can have access to them. If they are declared under public, functions outside the class can see and use them. By default, all components are set to private, so using that keyword is unnecessary, but it is good to practice and makes the code easier to understand. If a program tries to access a private component, a compiler error occurs. It is also good practice to make all variables in a class private and make public functions to be able to interact with them. This is what has been done with the rectangle class. We have made the attributes of width and height private so that they can only be accessed through class functions, and have made functions so that non-member functions can have access. We made two functions for obtaining the values of the rectangle, getWidth and getHeight, which will return the respective values. We also added two other functions to be able to change the rectangle's width and height if necessary to do so. How these functions are used in a program will be discussed later. Class functions, also known as methods and services, are written as normal functions except for the statement written before the name of the function. In our case, the name of our rectangle class followed by two colons. The two colons right together are known as the scope resolution operator. They are used to define the scope of the function by replacing rectangle between the return type and the function name. The function is being declared to be a member of the class rectangle. Because of this, it has access to all of the other members, functions and variables, that make up the class. Here we have the definitions for three of the functions of the rectangle class. The function getWidth simply returns the width of the rectangle object. The function setWidth takes a new value for the rectangle width as a parameter and assigns it. And finally, the function printArea prints to the console the product of the rectangle's width and height, in other words, the area. The function getHeight and setHeight would do the same as getWidth and setWidth, but for the rectangle's height instead. Because these functions are a part of rectangle class, they can use the private variables width and height as if they were non-member variables. They are written in the same way as other variables, whereas non-member functions would be denied access. You have to be careful when using these functions. As I said before, member functions have full access to an object's attributes. Even when a function is meant only to use but not alter the attributes of the object, it is still possible to do so. To further ensure that values of a class are not altered, and because member functions have complete access to them, one can make sure that these functions cannot alter them by adding the const keyword at the end of the function definition and declaration. This keyword states the class that calls this function as constant, so its values can only be seen but not altered. If the values are tried to be altered, a compiler error will occur. For example, here we've modified the printArea function to only allow it to see the rectangle's attributes. This function does not have any statements that alter the values of the object's attributes, but if by mistake one was written, a compiler error would occur indicating that an attribute was accessed without permission. It's good practice to make all the member functions that access but don't alter the values of a class as const to reduce errors in a program. To recap, here's the full code for the rectangle class. It has a set of attributes and services. We have protected its data by making it private and restricted access to it by means of public functions. We have also made an additional function that operates on the class's attributes and prints out the results, which is the area. On the next slide, we shall explain how classes are used by writing a small program that makes use of the rectangle class. The code for the class has been placed because it does not fit along with the program code. Have a look at it and we shall proceed in a moment. Here we have a simple program that creates a rectangle, gives values to its width and height, and then calculates its area and prints out the result. The comment section at the beginning of the program is a placeholder to where the code of the rectangle class should be. It was not added because of reasons of space. Before being used, an instance of an object needs to be made. The process is similar to declaring a variable, example, int number. To initiate an object, one writes the name of the class followed by the name of the object. Here, an instance of the rectangle class is made and called rect. Because the services of the rectangle class are inside the object rect, they need to be called through the object itself. To do so, the dot operator is used. To call a member of an object, you write the object name, the dot operator, and then the member you want to access. Note that this only works for public members. Here, for example, we call setWidth function by writing rect setWidth and then 5.2 in parentheses. The function then does its job and sets the width of the object to 5.2. After setting the width and height of rect, the function printArea is called, which prints the following. The area is 10.4. Here, we have made a completely functional program that uses classes to solve a given problem. This is object-oriented programming. To this, we shall add one last concept before concluding. Notice from the previous program that the values for the width and height of the object were set for the rectangle object before the area was calculated. This was a necessary step. Variables that are members of a class, like any other variables, need to be defined before they are used. Otherwise, they would give undefined values. Because of this, C++ implements a special type of function called the constructor function. This function gets called automatically when a class object is instantiated in a program, and it is used to assign default values to an object's attributes. Notice the constructor function for the rectangle class. The constructor function is declared similarly to a normal function, except that it has no return type and has the class name as its own name. For the most part, a constructor is just like any other function except for its format in which it is declared and defined, that it cannot return a value, that is why it doesn't have one, and it is not explicitly called. It executes only when a new object is created. That's why the constructor function has the same name as the class. It is called when the rectangle class is called to create an object. Just like any other function, the instructions that a constructor performs are defined by the programmer. The initialization values have to be defined by the programmer, otherwise they stay undefined. They also allow passing parameters and overloading. Notice the two constructor declarators with different parameter lists. One can also assign default values to the parameters to ensure that the object values are defined. In this case, if only a value for the width is given, the height value will be automatically set to 4.0. The function below these that only have a tilde, followed by the name of the rectangle, is called a destructor function. Destructor functions deal with making sure that an object is correctly deleted when an object is destroyed. Its workings are beyond the scope of this course, but is mentioned here for the sake of completeness. Constructors and destructors are not mandatory, but are always in good practice to avoid errors in your programs. Here is the same program, but now using constructors. Rect1 uses a default constructor which assigns the values 5.0 and 3.0 to its width and height respectively. Rect2 uses arguments to set its values 4.0 and 3.2. Rect3 uses one argument to set its width to 6.0 and lets the function assign its default argument for the object's height 4.0. After printing out the area of the three objects, the width of Rect1 is changed to the width of Rect2, and the area of Rect1 is printed again to see the new result. The program prints the following on the console. The area is 15, the area is 12.8, the area is 27, the area is 12. Finally, we have a fully completed program to solve the simple problem of obtaining the area of a rectangle. As programming solutions to problems become more and more complex, the use of classes allow programs to stay manageable by encapsulating related data and methods together. This allows these programs to be better structured, less error-prone, and easier to reuse for future programs.